So I'm going to talk about immersive visualization for large lectures. But before I begin, I understand from George that I have about 20 minutes, and then we should allow for 5 minutes pause or questions and so on. So that's what I'm going to be aiming for. Just in case I lose track, just let me know. This work wouldn't be possible without the great energy and the great talent of 4 undergraduates, Kabir, Maz, Sylvia, and Zuru. I believe Kabir and Sylvia are in the audience, so why don't you guys stand up and wave at everybody? Okay, maybe. This is an idea, a project that is very dear to our hearts. Ale, Bedrich, and I have been talking about using XR in large lectures for a while. So the motivation is easy. No matter how hard we try and how much we pretend, our lectures are fairly large. We're not going to reduce the student to instructor ratios with the popularity of CS and data science. And it is also probably fair to say, it is substantiated by literature in education science, that these large lectures just do not engage students the way they should and therefore are often ineffective. So you guessed it, our idea is to engage students using extended reality, so XR immersive visualization. So I have the benefit of the excellent presentation that preceded me. I don't need to tell you much about extended reality, but what we mean by that is essentially the ability to overlay virtual renderings, so graphics on top of the user's view of their physical surroundings. It has a lot of benefits. We're not going to dive into a comparison between XR and VR, but I do believe that XR has incredible potential in education and beyond. So why would we allow all students or the students in a large lecture to have XR capabilities? So one reason is obvious. All of a sudden, they would have the ability to see 3D visualizations, not just 2D visualizations. And also, they'll be able to interact with these visualizations. So what you see here is a concept. These are styrofoam heads, which will be replaced by students, of course, each wearing an XR headset. Here, the classroom is partitioned in 3 groups. Every group has their own copy of the visualization, this weird molecule floating in space. What you see here in pink is the instructor. The instructor has a AV control center of the future that shows this window eye here, or this screen eye shows to the instructor basically every one of the students with a dot and how they're partitioned into groups and so on. And the instructor keeps their conventional 2D visualization that they can manipulate and they can point to, while at the same time there is this virtual laser pointer that is kept in sync for the class to see where exactly the instructor is pointing. There are also 2D panels, a lot of 2D panels where you can display additional information. So this is one of the themes, one of the great benefits of XR, that you're essentially breaking free of the limits of physical displays, be it 2D or 3D. In this example that you see here, what we did is this is a concept image and you'll see its realization in a second, but the concept is to basically remove virtually the ceiling of the classroom to allow for truly monumental 3D visualizations to be seen by the students. And you can decide to peel off if you want, or to retract the walls even more aggressively. And by the way, this could be an interesting study. Like, should you leave the doors? Probably the doors should still be visible, right? For obvious reasons, for being able to leave the room, even though as soon as you remove your headset, you should be able to see the door. But nonetheless, you can understand how, and this has been said in the previous presentation, you can essentially transform any auditorium, any regular classroom into this 360-degree theater that allows for the class to be literally transported anywhere in the world, or to see any 3D data set. Now, beyond this instructor lecture mode, where all the students are looking at the same thing, XR has the great potential to allow for the classroom to be reconfigured, to switch from the lecture mode, from the instructor monologue mode, if you want, to working in small groups of students, which allows them to collaborate, to be proactive, to answer questions, and so on. So at the flick of a button, you can subdivide the classroom virtually into any group granularity that the instructor desires. without the expense of furniture that can pivot, or without having to deploy local screens and projectors or LCDs and so on. As you know, we have at Purdue a few classrooms that are physically reconfigurable, and they're very nice, but very, very expensive. And no matter how hard one tries to think of all the needs of a classroom might have, there will be only so many configurations that a physical classroom can assume. So I will tell you a little bit more about what happens here, but you see that and you'll see that in a second, the student group has the ability to request help from the instructor. The instructor is, again, this pink styrofoam head here, and they're able to see the instructor floating. So the instructor, without leaving their desk from the front of the classroom, can quickly crisscross across this or in this large classroom and provide help to individual groups as needed. All right, so this is the vision. As you guessed it, there are some challenges for implementing this. One of them is the need for headsets. Like George has said, the Quest 3 is quite a milestone in terms of XR technology development. The performance price ratio is at an attractive, maybe past the critical mass point. So we really think that that's something that could further improve and become cheaper and so on once it is deployed into large scale applications. I'm not going to bore you with technical details, but getting all these virtual spaces to be consistent and providing instructor-student group communication that is effective and so on are some challenges. So here is where we are. We have the ability to replicate the visualization for every individual student. Right now we have only 2 students. These are actually Sylvia and Mas, 2 of the students who are developing the system. Zero acts as the instructor, and you cannot see in this video that as Zero is moving his hand on the conventional 2D mouse, pointing at the visualization that he sees on his laptop, these virtual laser pointers are kept in sync with the pointing, and every student can benefit from knowing where the instructor is pointing. Of course, you can also go to a mode where you have a single visualization for the entire class. And remember, in that concept image, I showed the classroom being split into 3. You can, again, really choose any granularity for the subdivision of the classroom that one might like. Of course, you're not limited to stationary geometry. You can load any animation and any asset that you would want, and you can display it in 3D. And this is, obviously, you're seeing this on a 2D screen. Even though you have headsets there, maybe we should give this truly in 3D next time, this celebration of the Envision Center. But with the disparity between the left and the right eyes, you will really feel like this moving virus or whatever it is in fact in 3D and at a certain location in space. The other potential of 360 of XR is to transform the classroom into essentially into a theater. Here we remove the roof to transport the class into, I believe this is Times Square, so it's a 360 panorama that captures that environment. There are many other possibilities. This is a different viewpoint. This is from the top left corner of this 1142 room in Lawson that we have been using for our concept images and for our tests, preliminary tests. But you can see how you can actually look in all directions. You see the walls of the classroom that were retracted. You still see a little bit of the walls. Of course, there is no danger for the user to fall, but nonetheless, it is a little bit disconcerting to not have to be at a high elevation and to not have anything in front. We have some images of galaxies and so on, but they're nowhere near as nice as the ones that were shown before. So I'm not going to spend too much time on those. But you can, of course, play a 360 video. So in this case, this is a safari video, and you see these elements, these elephants roaming around. Let's see, this is the Eiffel Tower. You can look up. So you can have truly monumental sculptures. You can imagine an architecture class, for example, that would actually look at the building in full size from different angles, even impossible angles, and so on. But one of the early payloads, if you want, of our system will be to help with neural network education. This with AI education, if you want. So we plan to use it in an AI class as a first class. This is just a visualization of one of the networks that can classify handwritten digits, one of the great early successes of AI. Basically, the 3 is classified as a 3. But again, we're removing the roof here to be able to draw this complex and large network at scale in a bigger size. So this is our current progress in terms of individual groups. So you see these panels that every group has. These little balls that float above the students' heads will have the same color when the students are in the same group. So they will indicate to a student in the group who the other members of their group is. Again, the students in a group only see the, I'm sorry, my voice is so bad today, only see the visualization that is intended for that group. So they will only see the screen, the 2D screen with the multiple choice question in this case that pertains to them. So I'm wearing a headset that renders all of the graphics in the physical space. So I get to see what every single group sees. But if you were a student, you would only see your own 2D panel and your own 2D visualization. So let's see, past that, I don't know why this is repeated, but we have also gotten quite far along in terms of allowing for the instructor, and that's Sylvia here, who's sitting at the front of the classroom. She's being acquired by her laptop, and then and we have background subtraction working. In this video, we were just using a green background, but as you can imagine, since we are able to identify the background, or since we have that capability, we could also render it transparently. So basically the instructor, here we have only 3 students, but if you had 100 students, the instructor could very efficiently and ergonomically move in between any group that might have a question, might require a one-on-one communication with the instructor. So in this respect, obviously such an XR powered classroom greatly exceeds the capabilities of a physical classroom. Now, an important point is that we also want to allow the instructor to assume the viewpoint of any of the students in the class, because if the instructor is going to go and talk to a specific group far away from them, they should also see what that particular student or group is seeing. So what we're doing here, and I don't know that that's visible, easily visible, but what we're doing here is we're essentially stabilizing the view of this student using a homography, just a simple stabilization that reduces some of the abruptness of the view change directions. As you know, especially those of you who looked at someone what someone wearing a head-mounted display sees, you will understand that one first-person visualization is absolutely inappropriate for anyone else other than the person wearing the headset, because it is extremely unstable and it changes too much. So that's what this visualization is supposed to do. So it's supposed to achieve a better visual communication between the instructor and any one of the groups that are afar. So again, the instructor can assume a stabilized, if you want, viewpoint of any one of the students in the class. So where are we? Well, we're putting finishing touches on the system. We pretty much have all the parts working. We still have to. We do have IRB approval, which is important. We have some headsets. So I have 10 that are research headsets, but we were fortunate enough to get 25 from Dr. Lowell. So I believe I saw Victoria in that panoramic image. So thank you very much for lending them to us. And I'm also teaching a VR/AR class, but as you know, we're getting very close to when the final project is due, so it's not going to be easy in the next few days to have the students in the class participate. So that's where we are. This has been with the help of seed funding from Purdue University and Eli Lilly. And what is next is to secure funding for a robust implementation and extension of this system, and obviously also to disseminate it and to see it used. There are many questions that need to be answered at high level, like will the students own their headsets? Will the university provide them? Probably the former is the more viable solution. Our goal is to make XR, VR in general, but XR in particular, as common as any other piece of technology. We always, looking around me here, I have a physical keyboard, a physical 2D mouse, and I have an LCD. I should also have an XR headset here that I can put on to visualize some parts of my work that are better visualized in 3D, and then just remove it without thinking twice about it and continuing with my work somewhere in 2D and so on. So that's where we are. And again, thank you so much to all the students who contributed many hours into making this happy. What you see in this visualization is you see the local visualization that the group has, so they can work on their version of the visualization. They can interact with it, and then they can answer questions, or they can consult additional 2D materials as needed. So with that, I'm ready for your questions.
Voicu, can you still hear us?
Yes.
Okay. So everybody, I've turned on the ceiling mic, so anybody in the audience can ask questions. I can try to help field any of those questions for you, but this should work. Thanks. Sure. All right. We have probably a very technical question. Julian.
So the MetaQuest headsets do not give you camera access. How are you getting the footage off of the headset to the laptop?
So we got access from Mark Zuckerberg. No, just kidding.
I wish. Can you hook us up?
No, just kidding. I wish. As you can imagine, it is a problem. It is a big problem. There is about a section in our paper probably that will describe how exactly the laptop gets access to. We go offsite to a website, and then from that website, then we get the images back into the laptop. And in order to, I guess your next question, since you care about technical questions, your next question will be, well, how do I know the camera pose for the frames that I'm reading back with all this delay? So what Sylvia and everyone else in our group suggested that we do is that we encode as a watermark, if you want, the quaternion, the orientation. We only care about the orientation since we're using a 3D homography. So to encode the orientation of the headset in the frame itself, so that way it'll always be perfectly in sync with the frame. So we're reading back these frames from the remote website with an annotation of the orientation of the headset when that frame was taken.
That is extremely cool.
Yeah, by the way, Sylvia, who developed that, is right over there. So
I'm going to ask you all some questions.
I have a question, and Voicu, it's not scripted, okay? So we didn't play this before, but apparently it's a really cool technology, and there are two big problems with this. Number one is the content creation, and before content creation is the problem definition. And is there any fundamental educational theory that says there is a certain class of problems that require interaction, preferably in 3D, that would easily map to this kind of technology?
So I would like to ask my co-PI Ale to answer that question.
Thank you.
Also not scripted.
So definitely abstract concepts, non-visible concepts, complex concepts, those are the ones that are ready for this kind of technology, things that cannot be easily manipulatable in the real world. So we have to have these discussions of which topics and and going back to content creation, there is a lot of content on 2D and traditional web technologies, and the question is how can we leverage those, because we do have collaborations with developers who work on science education. So the content is there, we know what are the difficulties in learning, we know what are the misconceptions, we know how to provide interaction, so now we can do this. And actually the inspiration for this project was looking at levels of engagement. There is this theory that is called the ICAP framework. Basically, students learn more if they are just passive. They might learn something, but they learn more if they are active, and then they will learn more if they are constructive, basically that they are building things, and then if they are basically interactive, working with others. So there is a theoretical grounding on this project, and we are also defining forms of interaction as well, because it's not the same thing as the professor pointing than the students pointing and rotating themselves and basically decomposing a visualization. That's another level of interaction, so labeling and things like that. So I think we need that development and that integration, and we look forward to do the testing so we can validate these ideas.
Precisely my thoughts, yeah.
Yeah, thank you very much. That's actually going to be probably a very big conversation topic during our panel. So since we're going to be talking quite a bit about the impact of this in education, how we assess, how we validate, as well as how we compare that versus more traditional learning methodologies to establish, is there a major benefit? I think it's going to be a very interesting topic. I think we have maybe time for one more question.
Do you have? Yeah, just a
Sure, go ahead.
Yeah.
Go ahead.
So just a quick question. I was going to go back to the motivation of the study, which was how do you improve engagement in large lectures? And I have the same issue as faculty. So were you able to see improved engagement, or were you able to measure the engagement? Because if you have to invest 100 headsets, that's, you want to see, did I get 10% improvement or
So,
engaged?
so we have IRB approval. We have designed our study. We have not yet run our study. What we expect, though, and we will have quite accurate, quite objective metric of this, is we will expect the students to look a lot more at visualizations, to choose the views that they like, to be more engaged in the sense of not being on their laptop, to work in groups. We can measure how much each one of the group members contributes, but this is just a speculation at this point. We haven't run our study yet. But on top of, at some point, as you can understand, a longitudinal study that would deploy this intervention over an entire semester is not something that can be trivially done. But at some point, we'll get to that level, and we should be able to demonstrate differences in the amount of learning between a cohort using a traditional lecture where essentially students are on their laptop doing something else, and our lecture. In a way, this XR visualization also courses, if you want, and maybe that's a bad word to use, but it's sort of, you have little questions to answer. You have fewer ways of completely disengaging. We don't have any numbers right now. It is all a speculation. This is just seed funding, 6 months of hard work by 4 undergraduates, but we're optimistic. We're very optimistic.